All right, let's talk about one of Python's most essential tools, something I'd call a secret weapon for any developer from beginner to pro. We're talking about virtual environments. Seriously, getting this down is absolutely fundamental if you want to write clean, shareable, and, most importantly, conflict-free Python code. So if you've ever found yourself tangled up in a mess of package versions, believe me, you're in the right place.
So here's what we're going to cover. First, we'll dive into the why, the whole dependency dilemma. Then we'll look at how virtual environments are the answer. We'll walk through the actual commands you need to know, the Venv workflow. Then we'll peel back the curtain a bit to see how it all works and how it can break. And finally, we'll wrap up with how to share your project with others. Let's get to it.
Okay, Section 1, the dependency dilemma. Before we can really appreciate the solution, we've got to understand the problem. And trust me, it was a problem. We're talking about a level of chaos that developers fittingly nicknamed dependency hell.
This quote really nails it. Back in the day, things were, well, messy. Imagine this. You had your main Python installation, and that was pretty much it. So you had two terrible choices. You could install every single package you ever needed right into that one global space shared by all your projects, or you could just kind of dump the libraries into your project folder. Either way, it was a recipe for disaster and massive headaches.
And here it is, the classic nightmare scenario. This is dependency hell in a nutshell. Let's say you're working on Project A, and it needs an older version of NumPy to work. But then you start Project B, a brand new thing, and it needs the absolute latest version of NumPy. What do? If you upgrade for Project B, you break Project A. If you keep the old version for Project A, then Project B won't even run. You're completely stuck. It's a lose-lose situation with no easy way out. Or so it seemed.
So how do we fix this mess? How do we escape dependency hell? Well, thankfully, the answer is this incredibly elegant solution that's now built right into Python. It's all about giving each of your projects its very own private, totally isolated workspace. So what is a virtual environment? At its heart, it's just a folder, but it's a special folder. It's a self-contained directory that holds a specific version of Python and all the specific libraries that your project needs. The best way to think about it is like a sandbox. Every project gets its own little sandbox to play in, so the packages you're using in one sandbox can't possibly break or interfere with the packages in another one. Simple, but brilliant. Okay, so let's talk about this idea of activating an environment. It sounds really technical, but what's actually happening is pretty cool and not at all magic. When you run that activate command, all you're doing is telling your terminal, your command line, hey, listen up. For the next little while, whenever I type Python or pip, I don't want you to use the main system-wide versions. I want you to use the ones inside this specific project's private folder. You're just temporarily redirecting traffic. All right, we know the what and the why. Now let's get into the how. This whole thing boils down to a super simple 5-step workflow. This is what you'll actually be typing, and it'll take you all the way from starting a new project to sharing it with a teammate. And here they are, the 5 essential steps. This is really all you need to remember. First, you create the environment. Then you activate it. That's how you step inside that sandbox. Third, you install whatever you need with pip, just like always, but now those packages are going right into your little isolated folder. And now for the most critical step, number 4, you freeze your dependencies. This command creates a little file called requirements.txt, which is basically the blueprint or the recipe for your entire setup. And finally, when you're done working, you just deactivate. That's the whole loop. Okay, so you've got the workflow down, but what's really going on? Let's peel back the curtain a little bit. Understanding how Venv actually works isn't just for kicks. It demystifies the whole process. And more importantly, it helps you figure out what's going on when things inevitably break.
So how does it actually work? Is it some kind of dark magic? I mean, it sure feels like it when it saves you from a day of headaches. But the truth is, the way it works is surprisingly simple and really, really clever.
Believe it or not, a Venv is just a folder with a handful of things inside. You've got a bin or scripts directory, which holds a little pointer, a symlink to a Python executable. Then there's a lib directory, and that's the home for all the packages you install with pip. And finally, you have this tiny pipenv.cfg file, which is just a little note that tells Python, hey, this is a virtual environment. And that's it. No smoke and mirrors. This simplicity is the whole point. It's why they're so lightweight, so fast to create, and why you should think of them as totally disposable.
Okay, but that leads to a really common question. One you see plastered all over Stack Overflow and Reddit. Why did my virtual environment just go bad? You know the feeling. You step away from a project for a few months, you come back, and boom, the environment is just broken. What happened?
Well, 9 times out of 10, the culprit is that symlink we were just talking about, especially on Linux or Mac OS. Remember, your Venv doesn't usually contain a full copy of Python itself. It just has a pointer to the main Python on your computer. So what happens when your operating system decides to update that main Python, maybe from 3.11 to 3.12? All of a sudden, that pointer inside your old Venv is pointing to something that's changed or isn't even there anymore. The link snaps and your Venv breaks. But here's the beautiful part. The fix is easy. You just delete the broken environment folder and create a brand new one from that requirements.txt file. Problem solved.
And that brings us right to the final piece of the puzzle, which is arguably the most important one. This is all about how we use virtual environments to work with other people, to share our code, and to make sure our projects are perfectly reproducible.
So here's a question that trips up a lot of people when they're starting out, and it's a really good one. You've made that all-important requirements.txt file, but where do you actually put it? Does it go inside the environment folder or somewhere else?
And the answer, as this top comment points out, is definitive. You put the requirements.txt file in the main parent folder of your project, right next to your .py source code files. And the reason is simple. Your virtual environment folder is yours. It's temporary, it's disposable, and it's specific to your machine. You never, ever share it. The requirements.txt file, on the other hand, is the project. It's the permanent, shareable recipe that anyone can use.
This brings us to the golden rule for sharing projects. It's so simple. First, you add the name of your virtual environment folder to your .gitignore file. This tells your version control system, like Git, to completely ignore it. Then you commit your source code and your requirements.txt file. That is it. Now anyone on your team can grab your code, create their own fresh virtual environment on their machine, and run one simple command to install the exact same dependencies from your recipe file. That's how you get perfect, painless reproducibility.
Now, really quick, you've probably heard of another tool called Conda, so it's worth knowing the difference. Think of it like this. Venv is built right into Python. It's lightweight, uses pip, and it's absolutely perfect for standard Python-only projects. Conda is kind of like the bigger, more powerful cousin. It's super popular in data science because it can manage dependencies for any language, Python, R, C++, you name it. But for most everyday Python development, Venv is the simple, standard, and fantastic choice.
So I want to leave you with this final question. Is your code really finished if you haven't created a requirements.txt file? Because creating a virtual environment and that requirements file, it isn't just some extra optional step. It's not a nice to have. It's a core part of what it means to be a professional developer. It's the step that says your code isn't just done, it's complete, it's reproducible, and it's ready for the rest of the world to use. Thanks for tuning in.